All right, Milka, why are you absent? This is the most complicated concept this whole year in Algebra 2. All right, get your thinking caps on. Decide if you're doing winter soups yet. Okay. What is the name of that point? So, well, Mr. Eric, we need to have a scale, right? So like 1, 2, 3, 1, 2. Oh, okay, now if I have a scale on there, what's the name of that point? 3, 2, right? So you know that. Well, we've been doing that since Algebra Half, Algebra 1. We've done it a lot in Algebra 2. So the address is the x coordinate and then the y coordinate. And you put the two together and you have an x, y value. Call it the address, the coordinate of that point. And that works in a lot of applications. But there are some applications, particularly in physics, which we're going to get to. Well, we're teaching it this year, but you guys will get it again in 2 years. We do a lot of problems using a system where we measure from here, the origin, we measure the distance to that point, and we figure out what that angle is. Okay? So, that is called, this system is called the rectangular system, okay? And then this system where we have the distance along a hypotenuse out to the point and we have an angle is called the polar. And I always think it's cool that we talk about the polar system on a really cold day in January. It happens every year. As a polar vortex comes through, in Algebra 2, we talk about the polar coordinates, okay? So, let's figure out what would the address of that be? Well, okay, actually we're not going to go that way. They start with the polar and have you convert to rectangular. Okay, so let's say we had a length of 6 and an angle of 40 degrees. What that would mean was if we sketched it, we don't have to actually use a protractor, right, to measure the angle. Well, we'll estimate 40 degrees. Oh, and by the way, every time we do this, every time we do this, we always start at the 0 line, x being 0. So we start here and we rotate up. This is like 5 degrees, 10, 20, 25, 30, 35, so about 40 degrees. And then we get out to this point right here and we drop a line down to the axis. Make a little right angle out of it so we have a right triangle. Does this look familiar? Right triangle. Now, the 6 that's out front here, that is the hypotenuse. Okay? So this symbol up here, this is polar coordinates. The 6 is the hypotenuse, and then this thing inside the sideways check mark is called would be the angle. Now we can figure out what these two numbers are. Well, let's do this one first. Get your calculators out. This is opposite the 40-degree angle, isn't it? So what are we going to do? Sine, cosine, tangent?
Sine. Sine.
Sine, good. Michael, what'd you get?
0.64.
Is that the sine of 40?
Yes.
Okay, multiply that times the hypotenuse.
3.86.
3.86. Is that what you got?
Mm-hmm.
Okay, now let's do the adjacent side. So adjacent is caught another horse, so cosine. So we'll do the cosine of 40 times the hypotenuse.
6 or 60.
Is that what you got?
What did I
Okay, so the cosine of 40, and that's on the bottom of the magic triangle, and the hypotenuse is also on the bottom, so that means you multiply them.
Yeah, same thing.
Got it? Okay. Now we need to have a way to write this. Okay? So the 4.6 is on this axis. So we use the letter R because it's kind of to the right. Okay? So we use R for right. And then this is on this axis, and so we're going to use U for up. Okay? So the up and down axis, and this we call R. We could use X and Y, and actually we'll do that when we get to physics. When we get to advanced math, for some reason they call this I and this J. So, in this book we'll just use R and U. Alright, makes it easy to remember. R to the right, U up. Alright, let's do 7 at 230 degrees. Okay, let's be careful here now. Watch what I'm doing. How many degrees is it right here?
90.
Good. How many degrees is it right here?
180.
180. How many degrees would it be all the way down here?
230.
270. So 230 is back here, isn't it? And then we always go up to the x-axis. So if this is 230 degrees, since I'm dealing with this triangle right here, how many degrees is that angle? Right here. How many degrees? Well, 230 minus 180, right? 50? Good. All right, so now I know that's 50 degrees. What's the length of the hypotenuse? 7. All right, let's do the same thing. Let's find this, which is the sine. So the sine of 50 times 7.
5.36.
What is it?
5.36.
5.36? Okay. And then let's do this one, which is the cosine of 50 times 7.
4.50.
4.5? Okay. All right. Now, stick with me here. If this is positive R, just like this is negative X, okay, I'm actually not going to the right, I'm going to the left. But we call it a negative 4.5 R. If it's anywhere over here, it's a positive R because we're going in the positive direction to the right. But if I'm going to the left, it's not positive, it's negative right, which is left. Got it? It's on the negative axis. So negative 4.5 R. So what do you think this is? Are we going up? No, we're not going up, we're going down, but we don't use D. We say minus 5.36 U. Okay? Look at page 234. Turn to page 234. And example 2 actually is this problem, 7 at 230 degrees. And so they have it sketched there, and you see the 50-degree angle right in the middle of the page. And then they show the steps for solving with sine and cosine of 50, multiply it times the hypotenuse of 7. And you get the two numbers that we just got. And then they put negative in front of both of them. Okay? No, let's talk about this. They got 4.48 and you guys got 4.5. You guys got 5.36, they got 5.39. Do you know why that is? because when they, and you see in the step above, they took the sine and the cosine of 50 and they rounded it to do 2 decimal places before they multiply. But since we have calculators, once you do the sine or the cosine and you have it, the screen is filled with digits, it just makes more sense to say times whatever the hypotenuse is. Okay, so that's fine. So if your answer is off by just a teensy-weensy little bit, I don't mark it wrong. Okay, because I know you're using a calculator and they rounded. But if it's significantly different, then yeah, you mark it wrong. All right. Let's do one more, and then I'm going to have you come up here and do a few of these. All right, example 54-3. Read that one to me, Michael.
Change
Yep.
42,
At
340 degrees.
343?
340.
340. Okay. Well, think about it. All the way around to be 360. So if we're going to go to 340, we always go up to the x-axis. So how many degrees would that be? 20. 360 minus 340. We're going to be dealing with 20 degrees. And the hypotenuse is 42. All right, you use your calculator and find the sine times 42. You do the cosine of 20.
$14.36.
39.47.
Okay. 39.47 is on the right-left axis. So is that going to be positive or negative?
Positive.
Positive. So we always do the r first, just like we do x first before y. So we'll write r. All right, Michael?
Negative.
Negative. Okay. And that's on the up axis, but it's actually going down, that's why it's negative. So negative, but we call it the up axis. So negative 14.36u. Complicated, isn't it? All right, so we haven't done one in this quadrant. Okay, so I think we'll do one like that. And then I think we'll do another one down here just to get confident with doing these vectors. Now they have one more concept on page 235. And that is similar triangles. And they're showing that we can set up ratios when we do these. But we actually have been doing this already. Okay? But in problems like this in the past, they wanted you and assumed you were always doing scale factors. But I find ratios are always easier than scale factors. So I taught you the ratio method early, and now they're introducing it like it's something new. So it really isn't new. You just set up ratios. Now the thing that is a little bit different here is once you set up the ratios and they say solve for side A, for instance. So you get down there and you have B times C equals A times D. Well, if you're solving for A, then you have to divide both sides by D. If we're solving for D, then we divide, as I show here, both sides by A. And then the A cancels and you have D equals BC over A. So it's a little complex in that they're not giving you numbers, they're just giving you letters. Solve for one variable in terms of the other two variables. Not too bad. All right, come on up. And then I have a worksheet that you're going to do today. So you're going to do 10 problems today in your homework and a worksheet. Then tomorrow finish this lesson.